We have looked at bologna sandwiches. Now we're going to look at the stoichiometry of balanced chemical reactions. Same thing, but with chemicals this time. All right, so stoichiometry is the quantitative relationship between reactants and products. And we've said this, right? So this says one ammonia reacts with 2 oxygen molecules to give me 1 nitric acid and 1 water. Right, and we can use this balanced chemical equation to give us the proportions between the molecules or the moles of the reactants and products. All right, so if excess oxygen is reacted with 35 grams of ammonia, what is the mass of nitric acid that can be produced? So it says we've got 35 grams of this, all of this oxygen that we need, and we want to know about this guy. So the way we do this is we start with 35 grams of ammonia. In order to use the balanced chemical equation, we need to convert to moles, right? Grams, they're proportional, but we can't see it very easily. So we convert to moles, and then we can see the relationship. And the molar mass of nitric acid is an H, so that's 1.008. An N, that's 14.01 from the periodic table. And then I've got 3 O's. 3 times 16 is 48.00. Add that up, 1.008. Plus 14.01 plus 48. 63.02 grams is HNO3. Oh, what am I doing? I didn't need that yet, but I'm ready to go with it now. Ammonia is going to be 14.01, and then 3 hydrogens is 3 times 1.008 is 17.03 grams. All right, so remember, if I want grams of ammonia to cancel, I got to put that grams of ammonia on the bottom and moles on the top. And what's the relationship? All right, 1 mole of anything is going to be its mass from the periodic table, so 17.03 grams. And then I want to go from moles of ammonia, and I want to find out moles of nitric acid. That's the relationship I'm interested in. And what's the relationship? There's a 1 in front of the ammonia and a 1 in front of the nitric acid, right? We can't see. So it's 1 to 1. Then 1 mole of HNO3 is 63.02 grams of HNO3. Let's mash this in and see what we get. 35 divided by 17.03 times 63.02. I'm getting 129.5 grams of nitric acid. If we cared about sig figs, we should go to 3 sig figs, so it should be 130 grams of nitric acid. That's okay. All right, nice. So what did we just figure out? We said if we know how much ammonia we're starting off with, we can predict how much nitric acid we're going to make. Now the question is, with that same amount of ammonia, how much water can I make? And let's see. I'm going to start the same way. So the question is now, if I have 35 grams of ammonia, how much water can I make? Still have to convert to moles of ammonia, like we did on top. Now, what's the relationship between moles of ammonia and moles of water? They're all 1 to 1. That's not exciting. Moles of ammonia, moles of water, so it's still 1 to 1. 1 mole of water is 18.02 grams of water, right? Just add it up from the periodic table. 35 divided by 3 times 18.02. I get 37.0 grams of water. All right, so now we know, let me go to a different color here. We know that if we have 35 grams of ammonia, we're going to make 130 grams of nitric acid and 37 grams of water, right? These are all proportional to each other. It seems like we should figure out how much oxygen that is. Let's see if that's the next question. Nope. Oh, I'll tell you what I want to do. Sorry. Oh no, losing control here. There we go. Let's do this. So we started with 35 grams of ammonia to get 35 grams of ammonia to get 37 grams of water. What would happen if I started with 129.5 grams of nitric acid? Right? Oh, come on, man. Cooperate. This guy. What do you predict we're going to make for water? So 1 mole of nitric acid still weighs 63.02 grams of nitric acid. 1 mole of nitric acid corresponds to 1 mole of water. And then 18.02 grams of water equals 1 mole of water. And I think you know the answer. We should get something really close to 37 grams, shouldn't we? 129.5 divided by 63.02 times 18.02 equals 37.0 grams of water, right? So not surprising, right? We said that this guy corresponds to this amount of nitric acid. This guy also corresponds to this amount of water. So that means this amount of water must correspond to this amount of nitric acid. I'm sure there's some mathematical rule for that or something. All right, carry on. How many grams of oxygen are required to synthesize 78.8 grams of nitric acid? So now it's saying, if I have this, how much of this do I need? It's the same problem, right? So I'm starting now with 78.8 grams of nitric acid. And I got to go from grams nitric acid to moles of nitric acid because I want to use the balanced chemical equation. What did we just say that was? 63.02. Right, we already added that up. Times, and what's the relationship between moles of nitric acid and moles of O2? Aha, it's 2 to 1. So 2 moles of O2 equals that. All right, 1 mole of oxygen, I want to get the mass of oxygen, equals 32.00 grams of O2. Let me mash this in. 78.8 divided by 63.02 times 2 times 32 is 80 point. I'm getting 80.0 grams. How do you feel about that? That's O2. Let's take a second and just talk about this. I said 32 grams of O2 is 1 mole of O2, right? Sometimes people want to say, well, why don't I use 2 moles here? You could use 2 moles of O2 on the bottom, right? But then what's the mass of 2 moles of O2? It'll be 2 times 32, so it'd be 64.00 grams. So the point is, you can use whatever relationship you want here as long as it's true, right? It's simpler just to say 1 mole of O2 equals 32 grams, but you could use 2 or 3 or 5 moles of O2. It's up to you. All right, so we got 80 grams of O2. Okay, all right. So, I don't have these numbers. Oh, yes, I do. All right, so we already did this, but we're doing it again. How many molecules or moles do we have? 1, right? There's an invisible 1. There's 2 of these guys. There's 1 of these guys. And there's 1 of these guys. So it's 1 to 2 to 1 to 1 in terms of molecules or moles, right? They're both proportional. Grams, 2 moles of O2 is 64 grams, right? Nitric acid, we said, is 63.02 grams, and water is 18.02 grams, right? All this is from the periodic table. We've added it up already. What am I doing here? Oh, what happens if it's 35 grams, right? So if we have 1 mole, it would be 17.03 grams. Here, let's just start off. If we started with 35 grams, we know that that is 130 grams of nitric acid. We calculated that earlier. It was 37.0 grams of O2, and we just calculated that it was, was it 35? Did we do that? I don't think we did. I think, let me calculate this one quick. O2 would be 35 divided by 17.03 times 2 times 32. I'm getting 132 grams. We didn't do this. Did we do this calculation? No, we did not. That would have been better to do that, wouldn't it? Okay, I just did this. I just did another calculation. Same thing. This time I started with 35 grams of ammonia, and I figured out how much O2. Should I write that out? I probably should. Hold on. 35.0 grams of ammonia. All right. In order to use the balanced chemical equation, I need to turn that into moles of ammonia. And we said that's 17.03 grams. Oh, we could have done a proportion there. Ammonia and moles of ammonia. It's going to tell me about moles of O2, and it's 1 to 2. And then 1 mole of O2 equals 32.00 grams. And my claim is we get 132 grams. All right, so what this means is, and this is really all that stoichiometry is, so you can just talk about the relationships between all of these guys. So a way to say this would be, if I had 17.03 grams of ammonia, how much oxygen would that react with? 64 grams. How much nitric acid would that make if we had enough oxygen? 63.02 grams. How much water would that make? 18.02 grams. Right? And we're just talking about the relationships between these things. So I could say, how much ammonia do I need to make 130 grams of nitric acid? It would be 35 grams. If I wanted to make 37 grams of water, how much O2 would that require? 132 grams. Right, so all the problems, all these stoichiometry problems are just going to be going between these different masses, these proportions, back and forth. The story changes, right? So how much would you make? How much do you need? Those kind of things. All right, one more problem. So limiting reactant, right? This is the one that we're going to run out of first. So we'll either run out of ammonia first or oxygen first, depending on which one we have more of. And 35 grams, okay. Oh, 35 grams. We already said this is 132 grams. This was 130 grams, and this is 37 grams, right? We already did this calculation. Okay, so this is if 35 grams, then we'll make 130 grams. Okay. This is not very good, I'm sorry. The way I would do this, there's a couple ways, different ways, but one way is to say, if I had 35 grams of ammonia, how much nitric acid can I make, right? We've already done that calculation, right? Previously, we got this. So it would be 130 grams of nitric acid from 35 grams of ammonia. So let me just abbreviate that here. Gives me 130 grams of nitric acid. I'm going to do the same thing with water. 80 grams of water. I think I have to do this conversion now. I need to go to moles of water. Whoops. Oh no, tragedy. All right. Grams of water goes on the bottom to cancel grams of water. 1 mole of water. So that's 18.02 grams, right? That's just added up from the periodic table. And grams of water, moles of water corresponds to moles of nitric acid. And it's water 1 to 1. What am I doing? Oh, okay, good work by me. One should really start this video again because this is a tragedy. Can't even say tragedy. Grams of O2, so that's 32.00 grams equals 1 mole of O2. 2 moles of O2 corresponds to 1 mole of nitric acid. 1 mole of HNO3 is 63.03 grams. HNO3. Mash that in. 80 divided by 32 divided by 2 times 63.03 is 78.8 grams of HNO3. All right, let's have a think on this. So these are the important things. So if I had 35 grams of ammonia, I could make 130 grams of nitric acid. If I have 80 grams of oxygen, I can make 78.8 grams of nitric acid. Which one makes least, right? I run out of oxygen first. I make less nitric acid. Why can't I make 130 grams of nitric acid? Because I run out of O2 first. So the limiting reactant is O2 is limiting. All right. So 78.8 grams is how much we can make. This is what we call the theoretical yield. All right, so we can make 78 grams of that. Okay, so what was the theoretical yield of HNO3? We just said it was, in this calculation, 78.8 grams of nitric acid. And then, if we use 35 grams of ammonia, we've done this calculation, 80 grams of oxygen. All right, we figured out that the theoretical yield is 78.8 grams of nitric acid. So to calculate the percent yield, you take the, right, so percent yield, if you have time, write out your equations. So it's going to be actual over theoretical times 100. The actual has to tell me, so it tells me we make 75.5 grams, or 78.8 grams times 100, right? We calculated the theoretical yield. So that gives me 78.8 equals 95.8% yield. All right. All right, we'll practice some more